chat. And then I need to minimize that. And then I need to go here and share. Okay, cool. So that's there. That's done. Hey everyone, thank you so much for coming today. Thank you so much for bearing with me yesterday. I had a how do I say this? Yesterday was a very interesting stream because I ended up being unwell, and then basically we couldn't. I just had to break so many times during this. During the, how do I say this? During the stream, I had to break so many times. Okay, cool. So number one, at the end of the stream, there's going to be a link to the blog post that I'm going to be writing with this. And then at the end, the blog post will contain all the links that we basically want. What we really want to do today is just explore the, let's explore the, let me just do here. I want to do this. Give me this. Let me quickly. The aim today is to explore power management in Zephyr, device power management, and explore how we can build basically responsive devices that handle power management very well. Okay, low power devices. And what I'm going to do today is I'm going to start straight in the code. This is an implementation guide. This link, it's an implementation guide. I'll put this into the chat for those ones who are here now. This is an implementation guide, and what we're going to start is by adding power management to our device driver that we have. And then once we add power management to this, we will basically see how Zephyr does power management, and in being in the code, we can bubble out and explain it as we go along. So let's jump into the code immediately. And I want to git cd Zephyr project cd Zephyr. So let's get into Zephyr, and then git branch. Which branch am I on? Git status. I want to stash everything in here. Git control unlisted, include and route. So I want to stash everything in here so that I can just have a clean working directory. Git status. Okay, git stash list. Perfect. Yeah. Okay, so I do have this device driver that I'm working on. let's just pull it up and add it to the chat so that people can see it. So there's this device driver that I'm working on. Basically it adds I'll post this in the chat so that anyone, and put this in the chat so that anyone can have it. Oh wait. It's hard to use the mouse and the thing at the same time, but here it is. Okay, cool. And if I long click this, it should give me all the windows. If I want to get that one, and if I want to do that, and I want to get the chart, can I perhaps do chart as a tab in here? No, I can't. Pop chart back in. Can I close that? I will close that. And then what I will do is I will open the other window, the YouTube window, and then I'll try and combine these two so that, yeah, that way I can have this window running and I can have the chat running at the same time, and we can go with that. So I have this PR and it adds a device driver to Linux. Let's enhance this PR and perhaps add in some more power management, and in that way we can see how power management works, and also we can see how power management works, and we can kind of understand it intuitively by participating in power management. So let's go to sc118rs606.c. This is the file that I want to go to, and then I want to add I want to add a header, include Zephyr PM, and then I think device runtime. So amazing. So this is the first thing we've encountered. So the Zephyr has device runtime power management subsystem. Well, it's not really a subsystem. It's a sort of like it's a smaller system inside the power management subsystem. So we want to use this framework to enable our device driver that we're adding into the application to participate in the power management system. And basically the way we enable this is by implementing state transitions. So you see, look at here. So you have these transitions between state suspended and state active. And what you need to do is you need to do stuff like clean up, and you need to clean up all the pins you're using, save all your context, put all your stuff in an arranged fashion, so that you can when you're going into suspension or when you're coming into suspension. Basically, you need to start up things the way they need to be started up, and then when you're going out or into suspension, you need to stop them the way they need to be stopped out, and in the order that you want them or that needs to happen. Okay, cool. So let's jump back in the code and do this. It's easier. So that is the header we added, the device runtime header. And the first thing I want us to do is probably, we can just go down after the functionality, I think. Let's go down, where I'm doing, before I make the API, before I do the initializer, we can probably do it here. So let's handle, I think I'm allowed to do this. Power power management section. Okay, cool. So let's add some stuff. So let's just go, and for reference, I am following this. Just if you need to, it's already, the link is already in the if you're watching the video, the link is in the comment or in the description, and I'm following this guide over here. So I'm following this to transition between device power management states. So device drivers, Zephyr defines power management states, and then device drivers can implement callbacks so that Zephyr can transition your device into a power management state. The device itself never power manages itself, because the subsystem or the application might know more than the device. Okay, this is simple stuff. We'll talk about it as we go along. So let's implement these callbacks. Okay. Cool. So the first one we want to do is static int sc18is606 pm suspend const struct. Let's get the device, and yeah, just take the device. Okay, so this is a callback that will be used when we are going into suspend. Okay, and what we need to do here is basically we need to just look at it. So when we're going into suspend, basically this is the part. When we're going into suspend, we need to get the data and the configuration, because there's things in the data and the configuration that we need to, there's things in the data and the configuration that needs to be kind of cleaned up. We have some power pins. Basically we have these two pins. We have an interrupt pin, and we have an interrupt pin, and we have just a moment, Control E, press A, Control E. Okay, why don't you like that? Oh, construct, don't do that. Construct device. Okay, this is let's remove that. Okay, yeah, and then obviously this will return int ret. Let's make an int ret there, and then return ret, and then let's see if that works. That should make it work for us, and then I'll probably have a warning because I'm not uninitialized. Anyways, we'll initialize it later. So pf sc18is dash. No, it's not a dash. 606.yaml. Let's put a. Okay, so let's look at here. What I want us to see is we have a reset GPIO. We have a pin that we use for resetting, and then we also have a pin that we use for managing interrupts of this device. And basically what we want to do is clean up these pins so that they don't consume power, because it's a pin that has been set up as either as an input or as an output, but then it needs to not consume power. And then additionally to that, we have a semaphore that we use for tracking whether someone has finished an SPI transaction or not. I'm not so sure whether we need to clean up the semaphore during power management, but we will discover this. So let's just get in here and start doing stuff. So const context construct data sc18, yeah, and then let's call this data, and then this is a pointer to data equals to dev there you go, and then data, and then we need a construct sc nxp yeah, and then let's call that cfg, and then that is equals to dev, and then in dev we're gonna get the config, yeah. So we have the two things that we need to work with, the data and the config. The data and the config basically know about all the pins, all the semaphores, all the mutexes that we have, so it's cool. Let's now do the next thing. What we need to do in suspend, the first thing we need to do is we need to get the device, and then we need to get the devices needed, request devices needed by the device. Request the devices needed by the device. Enable pin. We don't have an enable pin. We have an interrupt pin and we have a reset pin. So PM runtime, PM device runtime get. What does that mean? Let's look at Zephyr documentation docs. So let's just run this thing here, and PM runtime get. I just don't want that. I don't want this here. PM device runtime get. What does that do? Okay, let's see it. This function will resume a device based on usage count. What does it return if it succeeds? In this case, if it succeeds, 0. If it's in this case, device runtime PM is not enabled and not available, this function will be a no, and will also return 0. If call would block it, but it is not allowed, e.g. in ISR, other negative error numbers. I don't know how to handle this yet. Is this runtime get? And what does it need? What does it take? It takes a device. This is insane. So this takes a device. So I need to know request devices needed by the device. PM device runtime get. Request devices needed by the device. Device driver? So this doesn't, okay, let's see. So let's see. Int pin, enable pin. But why in PM suspend do we let's just try. Let's just try and see what happens. And I am using DT specs, so int pin, you can just get port, config enable pin port. Okay, that's fine. Let's just let's go with and that would block. This function will resume the device if suspended. In case of a resume failure, usage count and device state will be left unchanged. In all other cases, usage count will be incremented. Then why are we calling this in PM suspend? I will find out in the code review. One of the easier ways of learning code is just write the code and then let them review it. And they will teach you. They will tell you where you're going wrong if it doesn't crash. Misra, we can't have more than one space. Okay, cool. So let's do that. So ret equals PM. PM device runtime get device PM runtime PM device, and then here we will take config, and then in config we'll take the int GPIOs, and then here we'll take the port, and then same thing for the, so here if ret less than 0 u, then we had an error, log error, could not get devices. What does that do again? What does that do again? Runtime get. What does that do? What does runtime get do? Yeah. Okay, I'll just bubble it up to whoever is calling. I'll tell the subsystem to deal with it. Could not get device runtime. I'll just tell the whoever is calling this, you deal with it. And then this is the error. You deal with this ret. And then return ret. Okay. There's that. And then if I just go here, let's go v, y. You see what happened there? Int ret. V J4. J. Okay, cool. So let's SP could not get device integer interrupt runtime. Okay, the other thing I have, other than an interrupt pin, I have a reset pin. So reset, port, and then also could not get device reset pin. Okay. So what do we do? So let's do that. Let's get those two runtimes. I think there's also a bus, but our bus, we are in our bus because we're at the level where we're getting the reset and the GPIO. The reset and the GPIO, they are set in the bus, not on the actual little devices. So okay, cool. So the first Okay, that's cool. So the first thing we need to do after we have this runtime devices, after we've gotten them and they're not, wait, do I? Yeah. Excuse me. I need a break. How do I make this? I need to be very careful with muting. This is a problem. So that happened today and yesterday. So what we've just done now by going through this little snippet of code that we've implemented, what we have just done is we have basically implemented a callback for a subsystem that knows more about the what is happening than our device driver, to put our device driver into suspend mode. Remember, the device driver itself does not, there's a power management subsystem, and the power management subsystem is in charge of making things go into power states. So what we do as the device, as the implementers of the device driver, we implement callbacks so that it's basically as if we're telling the system, hey, if you want to put me into suspend, call this function, and then this function will do all the work that needs to happen so that it can go into suspend. Do semaphore, Zephyr semaphore. So this is just a flag, and we use a semaphore in our code. We use our semaphore in our code. We use a semaphore here. We initialize a semaphore when we are starting. Whenever we have a GPIO interrupt, we use our semaphore to signal that the driver hasn't finished the transaction it was doing. So there's something that is doing a transaction. Here it is. There's something that is doing a transaction. When we're doing a transfer, we hold here. We take a semaphore. So we hold the signal that says, hey, we're doing a transfer, please don't take away this, take this away from me. And what I want to find out now is, do we need to do anything with semaphores when we're going into suspend? Do we need to deinitialize a semaphore? Okay. When changing, handling Zephyr semaphores in power states. Okay, I'll have to go and find out whether I need to clear my semaphore. So let's put in our to-do somewhere there. Let's put in to-do. we're in here. This is PM runtime get. Let's put in to do somewhere here. Let's put in a to do somewhere here. This won't be allowed to do. Check if I need to do something about the semaphore in suspect. I expect I will have to, because I have to do something about it for it in init, so that should make sense. Okay, cool. So let's do this also for the reset pin as well. So the reset pin is a little bit simpler. We just need to get the runtime, and if we've gotten the runtime, we need to ret. So let's look at that. We need to ret equals GPIO pin. We don't need to do anything. We don't need to do anything. We just need to get it, and we just need to remove it. All we need to do is remove it. GPIO, we just need GPIO pin set DT. Do we do set DT for the? Okay. No, we don't need to do something about this pin. Here's the thing, we don't need to do something with the... How do I handle... So here I probably send idle message to device. So if we go back to let's hook up, let's go into our documentation documents, and then that, and then that, and then that, and then we know we have our function that says idle mode. Low power mode may be entered by sending the idle mode command. So it's a target address, that's fine. Repeated start, and then F2 cross F2H. So let's see. I'm going to just put the here. What I'm going to do is I'm going to ret equals to pm get. Let's get the pm runtime device runtime get, and then CFG. I want the reset GPIOs field dot port. This might not need to be here, and then if ret ou log air cooled not get device reset run time, just be consistent, D, direct, and then that, and then return ret. Okay, let's now send the idle message. We have an idle message that we need to send. First of all, is this idle mode defined? Code 0 cross F2. Cool. And we have clear interrupt that we need to send. So this is broken twice. This is broken in more than one place. Let's deal with idle mode first. Config SPI. Why? Yeah. So here, once we've gotten this, and we put it ret equals to pm device runtime put, we can go cfg reset set dot port, and then we need to, if ret is under 0u, we need to go log error cooled not put the device reset GPIO, and then this happened, and then obviously it would come back, we give it ret, and then we go here and then do that, and then because this needs to be opened so that we can get our return ret, it would be nice, and then that, and then now here we need to do this, send idle message to device. SP. Let's do u int 8 underscore t buffer 2. Let's what? Okay, cool. Is that perfect? Buffer 0 is that, and CFG byte. Bro, I don't need this. I'm only sending 1 byte, man. Let's look at it. Let's look at it. So there's the target address. We're looking at an I2C message, not an SPI message. An I2C message. We have a target address. We have the right thing, say the right command, and then we send 1 byte, which is cross 2x, cross F2. So that fixes it. So that goes like basically we I don't I want red to be equals to this, but by the way red to be equals to that, but yeah, I can just return that red equals, because I've already put everything, and then now I'm telling this guy that is happening. Device, and then this buffer should be and idle, and then size of, I think this is just one, man. It's 1 byte. Something tells me I don't need to do that, because this is cannot take the address of an arbitrary int. Can I do that? Let's say qint 8 underscore t buffer 1 buffer, just like that, is equal to idle mode. I still don't know why this won't work, but I'm gonna do that. I'm gonna initialize it like that, and then in here I'll just come and send. That actually worked. Buffer size of buffer perfect. What did we just achieve? So what we have done here is we've basically released all the devices. We have released all the pins that this device is using. So the interrupt GPIO, the interrupt and the interrupt and the. I probably need to do something about the I2C bus. I don't know. Once I push this code, we will get reviews, and we might realize. So I have released all the pins that I need, and I have deconfigured them, so there's no pin that is basically left drawing power, and we're saving battery on that. And if the subsystem above my driver wants to suspend my device, it knows what it needs to do, because it just calls this function and it can suspend it. Okay, let's implement resume, and then we can see. So we can go into suspend. Okay. I kind of want to go up here so that I can see. I can see if I can add something else, and then let's add an extra line there, and then static int sc18 is 606 pm resume, and then this will take construct device, that will take a pointer to that, and then yeah. So let's think about this. Let's first get the data. Struct nxp, nxp, and nxp. Data equals dev. Get data from in there. Close data out, and then construct nxp con cfg equals to dev, and then we get the config out. And then now we need to go do the opposite. Let's request devices needed by. Let's request the devices needed by. So I'm basically now implementing this part. So what we've done is we've implemented driver suspend. So now let's implement PM resume. Okay, PM resume. So this is going backwards. Suspend and resume. Suspend is going to low power. Resume is come back out of low power. So let's implement that. There's that, and then the first thing we need to do is to get all our runtimes the same as below. So ret equals PM device runtime get, and then in here we want to do CFG, and then in CFG we want to get int GPIOs, and then in int GPIOs we want to get the port. So we want to get the runtime for that. If ret, let's go 0u log error could not get device interrupt runtime. You could actually, if we want to differentiate this, we can, because we can always be like for resume and GPIO for resume. That way, I find that it's really cumbersome to basically be so explicit, but there's this coding guidelines over here. And you will get clobbered if you don't do it. Coding guidelines. So there's this. They're basically based on Misra C, and they're a subset, and they make the code a lot cleaner and a lot more uniform. You basically, if you do it this way, one thing you might realize is there's not a lot of documentation comments in the code, but it's not because people are just lazy and they don't want to put them is because a lot of the times, if you follow these guidelines, the code becomes so clear you can just read it. Like you just go in the source and you can almost understand immediately what it's doing. There's no magic stuff happening really, so you can just follow along and see. You can literally read functions almost top to bottom and see what happens. And then if you have like good enough IDE stuff and you can go to definition and stuff of the sort, it becomes super easy. Let me take a 5-minute break and check for questions or such. No questions at the moment. So return ret. Where am I messing up? Oh, I know why I'm messing up. Int ret. So int ret, there's that. So now we want to go backwards. Anyways, let's keep going. We want to enable the device. If we want to enable the device, do I just statically enable it? I want to see how I enabled it before in init. Hey. Yeah. So I want to put it GPIO active, output active. No, this is reset. I want int. I want to put it into GPIO input configure. Do I need to run a setdt? Anyways, let's just go with what is in the example and then we will deal with that later when we go. So ret equals to pm. Let's set the dt. GPIO pin set dt. And CFG, and then in here we're going to take int GPIOs. I don't know if this is that. So I knew it. If ret is for you, you can kind of use functions, I think, so that you don't have to could not set int GPIO dt4. Assume I don't know if this is necessary, but and then you see here I need to somehow my n is always faster. 50J 100K. Oh, no 200J 50J. I want to see how I am handling the int GPIOs, so I need to do all of this. Yeah. I can just put this somewhere else. Oh, you see, I've met the semaphore again. I don't know if I need it. Is there an initialize? It feels irresponsible to just go and actually I feel like I should put this in a function and then call it twice. I feel like I should put this in a function and then call it twice so that I have only one place. But the problem is, do I... Yeah, let's just put it in a function. Let's put it in a function that takes the config. Yeah. How is a simple driver needing helpers? Okay. Return. Okay. Static int GPIO setup. Static int GPIOs setup. And what does this take? Const do you need the whole device? Construct device dev, and then I can always make data for you in there. Oh my word, this is amazing. I'll just run clown format right now, don't worry about it. It needs CFG. Static construct sc11 CFG equals dev. Struct dev. Data. Oh. Sleight of hand. Int. So shifting. Control R. Activate. Git status. Clown. Yeah, remove that. come before you. They need to come before you so that they can know it. They can not call you. Do you return a red? Okay, cool. So this is set up. Okay, so this is set up. What are you called? And what do you take? In GPIO setup. Okay. So that's here. Let's see. In its original rendition, where is red coming from and what is red? I don't need this, and it's considered something else. It's from somewhere else. So let's go fix it up here. Yeah, bear with me. This is from something else, and this does that error would anyways not tell you what was wrong. And then in here, after setting up, I kind of don't want to set it, but I kind of do. Is this necessary? I'll find out just now. And then I'll have int GPIO setup. And then here I'll take depth. Red equals yeah. So what have we done here? What have we done here? So we've gone back up. Let's go back to the reference code that I'm using. We have floated back up, and if you see here, they say you need to enable the device, and then once we've enabled the device, go through all of this, and then we can actually use ret there. That's fine. So we need to enable the device, and then if it fails before, we'll know. And then we need to do all the, you see, initial commands on device, in this case configuring the device interrupt out pin by using bus. Okay, cool. And then enable the interrupt pin. That's fine. Add callback, interrupt configure. So we've done that. And then I sort of need to go down here and remove some duplication of code. So this part, yeah, this part is gonna be removed. Let's remove that carefully. I know what I mean. So if, nice, actually. So I will explain what is happening here. Int and y, and then this will take depth, and then this will be like that, and then ret is equals to that, and then in here I will explain this just now. If ret is less than 0u, let's just do that, and then say log error could not set up device int GPIOs. And then this actually has some error. We can bubble back out and show it. So ret, and then that, and then return ret. Otherwise that should be good, and then that's it. Cool. What is happening here? Yeah, we don't need an else there because that and that, because this is not an implicit conversation. This is not an implicit conversion, so we don't need an else there. So that's fine. That's okay. Let's go back up. So now what we've done here is we've basically set up the int GPIOs bin. So let's do the same for the. We still have that semaphore. That is broken somewhere in this code, but we'll ignore it for now. We'll pretend like that is not a problem right now. Let's do the same thing for our enable pin. Ret. Okay, and also here we need to do if ret 0 u, and then log error could not set up the int GPIOs on resume, and then let's bubble up this value, and then that, and then ret, and then that, and then return ret. And then let's close that out. Let's now do the thing where let's set up the PM device runtime get CFG reset dot port, and is that, but what if it's not provided? Anyways, if ret, so u, what if it's not provided? Anyways, we'll see. Log error could not get the reset GPIO's runtime for resume, and then that, 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 and then return ret. Let's do that, and then once we have that one, let's now do the Do I need to reset the device? Okay, so after reset, we don't need the reset pin, so release it. So I'm doing this comment here. Let's just again highlight something. So immediately after you resume, you likely don't need your whatever, you're just in kind of waiting mode again. So let's give up the pin that we just took, and then after that we should have resume done. So ret equals to pm device run time put, anyways, cfg reset dot port, that's fine, and then y put okay, cool. So that is resume done. So now what's the next one we need? Resume done. Note that the interrupt phone is kept resumed, that it needs to be served the GPI when able. Perfect. Okay, cool. So now we need to implement turn off and turn on. Wow. Okay, let's go above this, but below that. So let's now implement static int sc18is 606 pm turn off. Okay, construct device depth, that's the point. And then in here, what do we want to do? We want to get them again. We want to do the same thing we were doing in suspend. So it seems as though for turn off we don't do all the deinitializing. We just like give up everything. That's what it seems like. You just go straight to like give up this resource. It could be because there's a button that has been pressed and you need to respond immediately so that the user can save power. So that's fine. It's still quite unclear, and this is a good exercise because now this actually shows me. Anyway, construct nxp cfg. This is cfg, and then equals to dev and then here take the config out. And then after we take the config, I don't know if we need the data, but I'll come back to that later. Did we use data in here? No, we never used the data in here. So if we never use the data, it's fine. And then let's do an int ret. And then after here, what do we do? So let's do pm. Let's get both devices. Pm ret equals to pm device. Let me see if I'm getting any YouTube comments. No, we got reviews. Okay, wow. So let's keep going. Let's keep going. I need to implement this. So get the enable pin, get the GPIO, turn that off. Yes, get in PM, yeah, runtime get, and this is the, yeah, if you're online and if you're watching right now, say hi in the comments. It really helps. It encourages me a lot. CFG, ask a question about the thing you're confused about. Make fun of me. GPIO's port, and then there's that. And then if ret 0u log error could not get device int GPIO run time for off. Yeah, send me a comment. I'm almost there. Let's finish this part. Let's finish at least implementing all the red. We need to just put it. I'm not gonna use the enable pin because you don't have an enable pin, so just put it. Ret equals to pm device runtime put, and then cfg int port. If ret is less than 0u, let's see, a log error could not put device int GPIO for off. Okay. Do the same thing for reset GPIOs. Why? We don't have an enable pin. And I want reset port. Reset. And then here I also want reset. Reset. Okay, and then we've done that, so we have released everything. We can die now. Go. can't leak power. Okay, cool. This is so funny because return ret. It's so cool. The reason this is so cool is because you read about, I don't know if you guys are like me, you spend some time and then you see what people are debugging in production, and people have things like, oh, my device finished its battery in however many hours and it was supposed to last however many months, and then you realize it's like, how do I say it? It's like this. There's a lot of minuscule. Let me finish. There's all this like little things that you have to go through your application to do in order for you to make sure that you don't end up consuming the. So think about things like. We have robots. We have robots in other worlds. Sky Live. The Sky Live. Yeah. We have robots in other worlds. So I want to see where Voyager. I think I want to see where Voyager 2 is right now. So we have a robot right now that's funny because oh, so many things. So last night it was 25 million kilometers away from Earth. Today it's 20 million kilometers away from Earth. And it doesn't really matter. But the point I'm making is, it seems trivial. Like, why are you going through all of these problems to save like just 1 milliamp of battery? And then you realize there's people who have robots that have been robots that have been running in other worlds from like this thing has been away from Earth for 40 years. It has code that it probably was built in Fortran or something, and it was probably like they spent months like a waterfall project, like, you know, defining all the registers and variables and everything, and they wrote pieces and stuff, and then you realize, like, it seems like so much trouble, but there's so much work because things like this need to run, and this is like a robot in interstellar space now. So leave this one alone. This is like almost too much. Think about like GPS satellites, GNSS satellites, probes that are at the bottom of the ocean, and they just need to tick back some data this thing sends data back at, I think, 160 bits per second. I don't know what the speed is right now, but how do I say it? It's so far away, and it's ours, and we built it. And if they didn't focus on like little minuscule things like this, it would have run out of battery. And that's not what you want. You don't want like your little satellite that's like in an unserviceable area in the world running out of battery, you know. So it's fine. So yeah, taking 2 hours to implement low power savings on a bus driver on a I2C to SPI bridge seems like a huge waste of time until you realize all of this little things matter, and because they matter, it rocks, man. Sorry. I'm just replying from messages from the group. So, anyways, back from my rant. It's like, this is why it matters to like build things like this. It just like, it takes so much time. Anyways, turn on. Let's implement turn on, and I'll be happy for today. I doubt any of my code is working, by the way, because this is, first of all, too much code to compile at once. But it's one of those things like you need all of them, because we need to go and implement callbacks below, and then anyways, and then we will see if they work actually. Const struct and xp. Okay, cool. So let's finish this, and then I have to like go jump in. Config. Let's say this is a pointer to config, and then this is dev config, and then let's implement an int. So let's see, what am I doing? I was inviting some people to the stream because they were asking about some embedded stuff. Cool, let's see. Okay, so we now want to implement turn on, which is, remember, we're implementing a callback to enable the application or whatever subsystem we're in to move us between power states. So now we want to implement a callback for the system to turn us on. Okay, we've done suspend, we've done resume, we've done turn off, we're now doing turn on. So we want that, and then let's do the usual, the gets of the devices. It feels like resume to me. I kind of want to do what resume does. It feels like we don't even know. It doesn't look like resume actually, but it does look like resume. So let's get GPIO set up, but I don't want to run that one. It doesn't seem like we're running that one. So let's just get them, and then it feels like I need to get them. Anyways, let's go back and put this in here. So let's make an int ret. So yeah, same questions. Set up. Do I need to set up? Do I need to set up this thing again? It's a bit, the documentation here is unclear. So here's what I'm looking at. The documentation here is unclear. Dummy driver turn on. And basically the thing here is, do we ensure we ensure the device is suspended, and if it is and if possible it is in its we ensure the device is suspended, and if possible it in its reset state. In this case, we are using an enable pin. For other devices, we may need to reset them by toggling a reset pin, using an SOC control, or writing a reset command to them. We do have a reset pin. We do have a reset pin. We do have a reset pin. So we can use a reset pin to do this. But is it necessary to go through setting up turn on set DT? Let's just get them. It's fine. This is why we need to do this. Let's remove this. Let's get in GPIOs, and then let's also get reset GPIOs. Why? P. All right. So down in init, we do a reset sequence somewhere, if I'm right. Reset GPIOs . Why am I doing this? Is because you remember the thing said we may need to reset them by toggling a reset pin using an SOK. You see, so I'm gonna toggle a reset pin. So that's it. Basically, we have a pin here. We do have a pin here. Let's go look at the pin out of this thing. We do have a pin here. We have a pin here. We have a reset pin that is active low. So if we pull that pin low, it should reset everything. I have a feeling quite a lot of what I've done is broken, but we have to do this first before we can. You see, one of the easier ways of learning this stuff is to just do stuff and have people review your code. And if you're doing something they need, they're going to review your code and tell you what you need to do so it works. So find something they need, do it, and then they'll tell you. They'll tell you if you did it wrong. And sorry, I kind of have to focus a little bit. Get integrated. Why are we getting runtime getting twice? Is it because we had already? I think I know what I did wrong. Okay. Okay, wait, something's wrong. OBS disconnected for some reason. Probably because we were doing what? We were messing up with we ran out of RAM probably. Okay. First of all, let's fix this issue here. Return reps. Let's go down here, and I want to call this reset thing. Yeah, this is definitely too much code to add at once, so we're gonna stop there. Anyways, I want to go talk to my friends. Why? Let's sort it out. Let's call reset here. Turn on. Yeah, that's going off. And No, I'm doing it. I'm doing it. This has to be called here. This has to be called. Look, we still need to set this thing up. It's what? What is that function we just made? This. Look. This is tricky, but if we just think about it, they do it. Reset int GPS, reset GPS. Why did I do that? Reset SP. Look, let's go back here. Look, they say this, and then they come back and they still configure that that interrupt pin. And then we still need to put these devices, which is so confusing. Oh my word. So let's just let's get these two puts here. Reset on that. Y. I probably can deduplicate this so much. Release devices needed for configuring. So what did we do? In turn on, we get the devices, like we configure, tell me which devices I'm going to use or I use, and then we configure them up, and then we go back to suspend. This is very usual for a lot of like RTOS type stuff or like embedded stuff. What you want to do is basically initialize in suspended mode, so that you start out with the device suspended, and then the next time when someone wants to use it, they will actually call for it, and when they call for it, you can now start spending battery on it. So now let's actually do the thing we need to do. So we've implemented all of this. We've implemented suspend, we've implemented resume, we've implemented suspend, resume, we've implemented turn off, turn on. So now let's actually apply them. Okay. Now let's give them to the power management unit. This was so good. Static int SC18IS606 PM action. Hey, look, it takes a I feel quite happy because this is actually quite significant. Okay, cool. So let's go here. Oh, by the way, this is what I'm implementing now. I'm implementing this part now. So this part hands it over to the Power Management system so that it can do stuff with it. So int ret, and then just go back and then switch action case whoa case PM device action suspend, right? And then in here, what do we want to do? Ret equals SC18IS PM. Okay, cool. Let's see how it works. Break. Case PM device action resume ret equals sc118 is dev break case PM device turn off. This is gonna be cool. I like this. SC18 IS 606 PM turn dev and then okay break. Okay, prop and then case PM device turn on ret equals to sc18 is 606 Okay, cool. So wait. I just need that. And then default ret equals dash in val break. Let's break that. Whew. Return ret PM device action action. Perfect. Then, since we have that, you know what we can do? This is cool, so cool, also cool. Dummy driver bound. Oh, and then now at the end of init, you see here at the end of init, we need to go like return PM device driver init dev sc18 is 606 PM action. And then that's it. Okay, not really. We still need to add the I thought we would need to do some stuff in here, but it looks. Where is the init used? Init and the init. I will not use the init right now. Oh my word, I have to implement the init. So look, oh my word. So we have to implement a init function because it will, oh wow, this is unending. Keeping satellites alive forever is hard. Come on. Let's see. Static int sc1 8 is 606 d init. And what does that take? It takes obviously construct device dev. Guys, I have to stop because I have to answer this call. But what I'm going to do in the rest of for the rest of this code is I'm going to implement the init, and then I'm going to push up this branch, and then once this branch is ready and you guys can look at it, you can let me know, and then I'll do some follow-up on how this went. So thank you so much for coming today. It was awesome. It's been awesome, like hanging out here, writing code and building with you guys. I'm really impressed with the things I learned today conceptually, because once I start building this, it's gonna break, and then once it breaks, it's gonna teach me something else. Thank you for coming. Leave a comment, request what you want me to do next time, and thank you for hanging out. Cheers.